Hey Finxters, and welcome to this complete guide of the Python modulo operator. My name is Christian Meyer, I'm the founder of Finxter.com, and in today's video I'm going to show you one of the most important built-in functions in Python. So let's dive right into it. So the Python modulo operator is one of many arithmetic computational methods in Python that you can use right out of the box without importing anything, and it calculates the modulo of a certain computation. So what is the modulo? Modulo is just another name, fancy name for remainder. So you have like a division operation here with two operands, the dividend, which is the first operand of the division, and the divisor, which is the second operand of the division. So say you calculate 7 divided by 3, then you would obtain the result 3.5. But if you use integer division, so like you have learned maybe in preschool, you have integer division, so you have 7 divided by 3 using integer division. The result is 2 with the remainder 1. And 1, this remainder, is just the modulo. It's the result of the modulo operation. And you use the percentage symbol in Python to express this computation. So if you see the percentage symbol, there are only two different meanings it could carry. And the first one is modulo, which is the most frequent meaning of the percentage symbol, and the second one is string formatting. But so if you see the percentage symbol in combination with numerical values like numbers 7 and 3 or even float numbers, then it usually means the modulo operator. Good, so let's dive into some examples of the modulo operator. Say we have, I will have a maybe practical code snippet here. So if you you will use the modulo operator, for example, in a for loop to basically loop over a certain number of values and perform a certain operation only for a subset of all the values of all the loop iterations. So for example, if you loop over loop variable I, taking values from 0 to 10,000, now you want to perform an operation only every thousandth step in the loop iterations. Okay, so and how can you do this? Yeah, you can use the modulo operation. You simply calculate I modulo 1000. So you divide. Think of it as a division of I and 1000. So you divide I by 1000 and obtain the result. Obtain the remainder of this division. And if the remainder is 0, this means that I has a number 0, 1000, 2000, 3000, 4000, because those numbers are multiples of the number 1000, and therefore they divide without remainder, and the modulo operation is 0. So this is one of the common ways of using the modulo symbol. And if we enter into one of those, then we print the number that for which the remainder is 0. And you see, so we don't print all 10,000 values, we just print the values where the remainder is 0. Okay, so this is one common operation. Something that many people don't actually know, even advanced coders don't know this, is that the modulo operation has so you can also use floating point numbers to perform modulo computation. So what does that mean, a floating point? So you know, okay, so if you have the example 7 modulo 2 and we print this, then the result is 1, yeah, because we divide 7 by 2, which is 3, and the remainder is 1, so this is the result of the modulo computation. But what does it mean if we have one float value in it, so like 2.5? So then it is still defined in Python. You can still calculate 7 divided by 2.5, which is like 2. So and then you have a certain reminder. So 2 times 2.5 is 5, and starting from 7 means that there's a remainder of 2. So the result will be 2.0. Okay, you see it here. And you can also have like one operand can be a floating point operand, but you can also have like 2 floating point operands, like 7.5 and 2.5. So what is the result now? Maybe you can pause the video and think about this before I move on. Okay, so the result is 2. Have you printed it? No, so the result is 0.0. There is no remainder, right? So if you calculate 7.5 by 3.5, it just matches up. There's no remainder. Okay, so this is like a common technique, not known by many people, that the Python modulo operator also works for floats. Then sometimes we will see like code like this in if statements. So maybe let's just quickly go over this example to improve your understanding. So again, we have a loop variable. We even don't need this. We go for I in range 15, and if I modulo 5 is 0, so basically this is same usage as here in the for loop, right? It's exactly the same usage. So maybe it's redundant to even discuss this. Okay, now let's dive into some very interesting example. I found this really interesting when I just learned about the that modulo also applies to negative numbers. And what is the meaning of modulo with negative numbers? So there are 3 cases basically, yeah. So we can have like 7 modulo 2, both are positive. We can have the divisor being negative. We can have the dividend being negative, and we can have both numbers being negative. So these are basically 4 cases, yeah. Here we have both are positive, here the divisor is negative, the dividend is negative, and here both are negative. So what would you and you see like 7 modulo 2 is 1, right? There's the remainder of 1. So what would you guess? What is the result of this computation? So the rule is pretty simple if you know about it. It will always the absolute value of the result will always be 1. But now the question is, what is the sign of the absolute value? So before the absolute value, like do we have -1 or do we have 1? So these are the 2 cases that are possible in our computations. And you always like there's a rule that the modulo operation always gives us in Python the sign of the divisor, so of the second operand of the modulo operation. So if the divisor is positive, the result the modulo operation will be positive. If it is negative, it will be negative. And there's no cancelling out here. Like for example, if you divide -7 by -2, you would cancel out the minuses and the result will be positive, right? But there's no cancelling out here. So if you execute this, you see in the last case we even have a -1. So this is just by definition, and I have checked this on Wikipedia as well, and there's no like clear rule, mathematical rule that the sign always is the sign of the divisor. This is just an implementation issue for Python and some other programming languages. In fact, I would say the mathematical more precise way would be to actually allow for cancelling out of negatives, and to also look at the dividend. But in Python and in other programming languages, for some reason, they just decided to go this route, which it's still fine. I think it's just a definition. It's just how you define certain statements, and then the implications of this definition determine whether the negatives would cancel out or not. Okay, but just as a rule of thumb, the modulo always has a sign of the divisor. Okay, so the second operand. Good. Okay, so I think we have basically checked most solutions. In the end, I will just give you one quick puzzle that you can check. So let's have a new code block. The result of print 51 modulo 3. So what is the result of this operation? You can pause the video also. The result is 0 because 51 is a multiple of 3, so it divides without remainder. Good, okay, so that's it. Thanks for listening to this video. To sum up, the modulo operator takes 2 operands, the dividend and the divisor, and it performs integer division and returns the remainder of the division. And if you have negative numbers, it will return the sign of the divisor as the result of the modulo operation. and you can use it also on float numbers. So I think these are the two interesting facts I got out of studying, diving a bit deeper into the modulo computation, that you can also apply to negative numbers and to floating point numbers. And what happens, of course, you also need to understand what happens. If you want to learn more, then check out the link to the blog article that I just published about this topic, and also check out our email academy, where I will send you a lot of Python lessons and Python courses, Python tutorials that are completely free to access for you. Courses such as Python cheat sheets, NumPy, pandas, basics, keywords, and lists and sets and data structures and algorithms and machine learning and data science. So we have many courses about different topics, and all of them are freely available via the Finxter email academy. Thanks for listening to this video. If you like it, give it a comment, tell us how we are doing, and thanks for watching this video. Bye.